hope you guys are doing absolutely fantastic. Welcome back to the channel. And I have been thinking about like starting a career related talks which all guys wonder about. So we have Ayan Pahwa, who is into the embedded domain for last 6 years. Also he runs a YouTube channel called CodeNsolder, in which he talks about drones, embedded and IoT, 3D printing and much more. So we will be knowing about his embedded journey as well as the future scope in embedded. So stay tuned till the end. This video can get pretty long, so put on your earphones and watch it like a podcast. So without further ado, let's hear it from our guest. So I was thinking this kind of a series from a long back, and of course I wanted to start with the embedded because I am into electronics from the start, and from the very start I have like you in mind, because I believe that my journey started with your video in career in embedded. That was a great video on your channel. So I myself have learned a lot around your channel, starting from the embedded to the 3D printing. A lot of peeps out there have learned a lot about embedded, IoT and multiple stuff. So we will be talking all those things today. So before that, can you please introduce yourself, like what you do, what is your educational background, and what areas are you interested in?
Yeah, sure. Happy to be here, Saurabh. Thanks for having me. So I am Ayan. My name is Ayan. I work as embedded systems engineer. So before currently I'm working for a company called Balena IO, which is an IoT fleet management company. I just started working for them as a developer advocate. Before working for Balena, I worked for companies like Siemens, Metagraphics, Mercedes, and another few companies which are in similar domain. My primary work area, or you could say the interest, is embedded systems, more specifically connected devices, Internet of Things, and different things revolving around it, like connected cars, drones, and things like that. Apart from that, I believe I am a maker at heart, so I do a lot of making things, projects, documenting it, blogging around drones, 3D printing, some mechanical stuff here and there, electronics, PCB designing. So yeah, that's about me.
Yeah, that's great. So I myself have learned a lot around your channel. So basically you belong to electronics and instrumentation domain, and I believe around 70% of this domain people are shifting to IT right now. But like I would like to know like how this whole journey started, like from this Arduino ESP's 8-bit Arduino to like 32-bit this Texas Instrument board, and exploring this Raspberry Pi kind of thing. So how did this whole embedded journey of yours started, and what were your initial days, projects and internships, like from first day to getting placed?
Right. I see you have a lot of amazing boards out there, but so yes, I am from engineering background, which is applied electronics and instrumentation. It's not very common, but it's very close to electronics and communication. There is just a couple of subjects difference here and there. About my journey in embedded system, it started way back when I was in first year actually. So I have a couple of seniors who were doing some electronic stuff, and I had no idea that you could actually program something that's made out of silicon and turn some motors, build some robots. We do have a robotics lab in our college back then, but I was not really part of that. I would say the turnaround point where I thought, okay, this is serious and I need to look more into it, is after attending a couple of technical fest. One of them happened to be the BITS Planning Technical Fest Deposit, where we went for a competition for a hovercraft, and that was, I think, the moment where I see a lot of projects around embedded systems, and I gave it a very serious thought. So that was a 1 week fest, and we really enjoyed it. So after coming back, I seriously researched about it, went on Google, went on IEEE Explore, searched for different things, and obviously came around Arduino. ESP was not a thing back then, and Wi-Fi was still very expensive to interface with the microcontrollers. But yes, Arduino was definitely there. So did a lot of sensor project, did a lot of motor projects. Here and there, subscribe to magazines. One of them I could remember is Electronics for You, which I later wrote for some articles too as well. But yeah, I think awesome. that was the point where I started, and from them we also started organizing some events at our college, and there was no going back after that. It was just like you put on a field and you just start working on it. Talking about internships, I try to when I was in college, I tried to get internship at least once in every semester. Though I couldn't do that, I ended up doing 6 internships in total. And I was lucky to find some people who I could say was a good mentor to me, directly or indirectly. So I knew that I have to do internships in different domains to have a wide variety of knowledge which I can bring together. So yeah, I did one internship in networking that was in voice over IP and IP cameras. That gave me a really broad knowledge of how networking works, how different protocols, DNS, IP, DHCP, Internet Protocol, UDP, TCP, things like this work. And that in some other years of my engineering, I did some internships which were totally based around microcontroller, and some were totally based around Linux. So in all, when I was completing my undergrad, it was having a good chunk of experience in different domains and bringing them all together. The IoT was really hot that time, so I think that was the time I decided I'm gonna make a career in Internet of Things, because I had a good knowledge of networking, I had a good knowledge of microcontroller, and single board computers were getting quite popular. So yeah, that's from where I started my journey. And every internship, every mentor, every event or hackathon or things like that, they just were small bricks that kept adding and made this stronger wall of a career.
Yeah, I believe because this ESPs were coming around 2014 or something, and you pass out around 2015, and of course this Raspberry Pi and Beagleboard was coming around. So it was the great time to explore all those stuff. I believe that was the peak period when people were talking about this stuff and communities were like active in this whole journey. So now you have a dedicated video on how to make career in embedded domain, but these days this roadmap is getting hyped. So can you please summarize embedded roadmap briefly, like which softwares and hardwares to explore to get into this domain?
Yeah, actually, it's if you look at it from a top side view, it's never about a hardware. It's never about a software. It's more about the intent behind it. So, I always say to people who are into college, and I still interact with a lot of people who are into college, whether just meeting them in community meetups, whether they're calling me for some talks, or whether we just going there hanging out with people. I love doing that. So I always like to say that when you are young, take a very wide variety of experience, and when you are gaining some professional career, you're starting a professional journey, then try to go deeper. So what I mean by that is, when you are in college, try to get your hands dirty with different technologies. It doesn't have to be just embedded. It could be front end development. It could be application development. It could be learning how to do welding, right? So a lot of different things. You just need to get your hands dirty with different things and check what things you are liking. When it comes to embedded, it's actually you mentioned my video, and that video I did a lot of efforts putting that video and also a thread later on Twitter. So that's very specific for embedded, but it doesn't have to necessarily be starting in college. If anyone wants to do that, they can also do that after college, after 5 years of career. That doesn't matter. So how a roadmap actually looks like is, you see embedded systems is a combination of hardware and software, and there is another stack which is being added here, which is called internet, because of smart devices, connected devices. So what I would suggest anyone who would like to make a career in embedded system is start simple and just start making projects. It could be very simple projects like just reading temperature sensor, rotating some servo motors, and over the time just scale over top of it. So you can start with microcontroller. Arduino is definitely one of the very popular choice because of the total combined ecosystem, which is very flexible. But at the same time, I don't want you to just be constrained in embedded system, because embedded systems, as I mentioned, is not just software or not just hardware. It's so much more. It's about problem solving in consumer electronic space. Like if you look at the projects, the actual products of embedded systems in today's world, you could see a lot of applications in automotive. You could see a lot of application in consumer electronics. Your phone is an embedded system. Your microwave is an example of embedded system. So it's a pretty huge field, and you could be one of the generic embedded developer who could write firmware, or you could be a very specific embedded developer who who knows the shit around the let's say the power management thing, who knows the shit around, let's say, the IoT protocols. So that's why it's a very massive field, and you need to just start somewhere and keep exploring, and things just start to pop up. So again, my recommendation would be to start anywhere, whatever you can find locally. Buy some sensors, buy some microcontroller boards, buy some single board computers, and just start hacking around it. You might mess up something here and there, but at the end of the day, it's not that expensive, so to speak. And do attend a lot of events happening in different engineering colleges and hackathons and things like that. Meet people, go to communities. That's more important than just sitting in front of your computer coding, because when you go out, you see a lot of things happening, and when you come back, you can research about it, you can collaborate, and that's where the real knowledge lie, in my opinion.
Yeah, yeah, that's awesome. So, from the college, this is one of the most requested questions from my friends as well as from juniors. So, what are the best option when it comes to masters in embedded, either in MS or MTech? What are the best colleges or courses out there?
So here's the thing. So when you say about masters in embedded system, that's again a very generic term, because when someone is going to pursue a master's degree, they need to be a little more specific, because a master in embedded system is again a very generic term, and I won't consider that person a master, to be honest, because it's again embedded system, as I mentioned, is very wide. So you need to be more specific. Like for example, you could do masters in control system. That would make a lot of sense. Knowing about the algorithms like PID, knowing about Kalman filtering, and researching about this. So I don't know. It's a really not a right question to answer, because, in my opinion, master is a very specific thing. You need to know, I'm going to be doing research in this department, and your motive should be to do a lot of research, write, publish a research papers, go for patents and things like that. But just to answer, for the sake of students who have this mind, embedded system master is a very generic thing. Don't think that you are going to be doing that. Master is a very research oriented program. You have to be putting a lot of efforts and try to come up with the new things that never have happened before. So think of it more like going very deep in that thing. So where you need to do master, should it be in connected devices? Should it be in power supplies? Should it be in, let's say, control system? Should it be in piezoelectrics, where, so that level of detail you need to think. And I don't expect a first year or a second year student to know this much into. That's why I always say to explore all the fields that are in embedded systems and different domains, and then see where your interest lies, what you want to pursue, and then go for masters. I have no master's degree. I haven't went to abroad to study, or even in India. For me, it was always learning by doing. That means working in companies, working on different projects and products. But yeah, that's always an option. If you want to pursue research, then only uh, go for masters, because that's a more research oriented thing instead of learning. You will learn more in a job than by researching in a college, that's for sure. But if you want to research, if you want to contribute more in this field in terms of a scientist, then go for masters.
Yeah, 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 definitely. And when it comes to research, I have a question for you. Like, you have been exploring a lot about Bluetooth security and hardware security, especially since your college days, and demonstrate a lot about Bluetooth string manipulation. So now this IoT thing is coming up. So, what are your views on IoT hardware security, and what are the major challenges you believe that these days are?
So when I first published one of the IoT security research which I was doing, the thing that strike me is the only way to stay safe on the internet is to stay disconnected from it. So once you are on the internet, there is no 100% guarantee that you are safe from attackers. You have a zero vulnerability. You cannot get compromised. There's no guarantee to that. So the only way to stay safe on the internet is to stay disconnected from it. That's what I say. But again, it's not happening. We live in a world where everyone's connected. You are staying in Maharashtra. I'm staying in Delhi. We are talking in real time. There is it's impractical to say that let's disconnect all our devices. More in the time when IoT is hyping up, machine learning is hyping up. Everyone needs data. So what I'd say that IoT security is hard, and the reason is because it's a very new and people haven't figured out really what we are going to be doing with that. So everyone wants to harvest data, everyone wants to communicate with each other. They might have some idea of what the end product will look like, but again, it's still a very nascent state, I would say. So that's why you could see a lot of compromised devices. So IoT security is hard. Hardware security is harder. Like I was reading this article a couple of weeks back where the new Apple AirTag was cut open by a security researcher and it was compromised. So if a company like Apple who give attention to details, if their products can get compromised, their hardware products, so I don't expect a small startup uh, giving that much attention to the security detail. So all I could say is uh, number one, which I always say to the companies, don't compromise security to reduce time to market. That's what happened with my research. So this bulb company, they were in such a rush to bring their product to the market that they forget, or I would say that they totally neglected that someone could actually reverse engineer it, someone could sniff the packet. So there is a cutthroat competition going on in the market. Everyone wants to bring out their product early, and the first thing they compromise is on security. But that's not the right thing to do. Uh, so when millions and millions of devices are connected to the internet, if they go to the wrong hand, there's a huge chances that they can become botnets. So botnet is something that a hacker can use your device to attack other people, and end of the day, it's your fingerprints who that will left behind. So yeah, things look shady, things are hard, but I am seeing a lot of improvement happening. The only thing you can do is make it harder to hack, but it would never be impossible to hack.
And the existing protocols are do you think it are sufficient for the IoT devices right now which are into market, or they
So
need to be yeah.
so everything is sufficient until the day you wake up to find it's not, right. Uh,
Yeah.
so yeah, I mean, there's something called zero day vulnerability. So it's a vulnerability that's very recently you know got discovered. So Intel could never imagine that someone could find a bug in their silicon and have a Spectre and meltdown I'm talking about, and have that sort of vulnerability in their CPUs. So software security you can patch over the air. You can send an update, you can fix, but how will you patch a vulnerability which is in your CPU, in the silicon?
Yeah.
So to answer your question, everything is sufficient, everything is full of features until you wake up the day and you find it's not, it's compromised. So that's the process. You discover it and then you come better next time.
Yeah, definitely. And coming to next question, this is one of the most trending topic nowadays. I am the people who are coming new into the communities. So this is one of the most trending topics. So what do you think? What technologies will define future in embedded domain?
So I think I was talking to a couple of people in the community, and I had this vision of Industry 4.0. So Industry 4.0 is another very hype thing. But if you look at it, in my opinion, there are there are 3 to 4 pillars of this entire Industry 4.0 concept. The number one is IoT, which is connected sensors, connected devices, so you can remotely control on and off for different devices. You can remotely monitor it. But the biggest thing is you can generate data at some point and you can transfer data to another point. So IoT, the first pillar, will be generating lot of data to process. That would be a big data. So the first pillar is IoT. The second pillar is I would say artificial intelligence. So AI, they need training, right? Machine learning models, they need training. And to get trained, they need data. So the first pillar, IoT, is generating a lot of data. The second pillar, the artificial intelligence, will consume that data and will become self-reliant. So for example, excuse me. So for example, there could be a small device attached to your fan, and there could be thousands of devices out there. The fan company sent it built in, and it has a very small accelerometer which is just generating data and sending it to the fan company. So over the period of time, what a fan company can do, they can add a machine learning model to it. And if there is some anomaly in data, it could say that the fan is going wrong, the motor needs repairing, or the fan needs greasing, things like that. So coming back to the industry 4.0, the first pillar is definitely IoT, which will generate a lot of data. The second pillar is artificial intelligence, which will consume that data and make our devices self-reliant to take their own decisions. The third pillar I would say is a blockchain. So blockchain is basically a distributed system where no one controls it, but it's a self-functioning, self-reliant system. And the reason I say blockchain comes into picture is more specifically because of something called smart contracts. So when you are consuming someone's IoT data, there could be some sort of smart contracts that I'll pay you this much bitcoins, I'll pay you this much Ethereum, and in return I want your data for, let's say, 1 year or 2 years. So this kind of smart contracts I will be expecting to see into the future, where there is no person involved. So the smart contracts will automatically execute, and the data exchange or whatever happening will happen. So yeah, to answer your question, the in embedded system is a very small dot in this entire ecosystem. If you look at the top up, I'd say IoT is the first pillar, the second pillar is AI, and the third pillar is definitely blockchain. So that's my vision of industry 4.2.
Yeah, definitely. I would like to add couple of thoughts to it. Like I was researching couple of weeks back that the term digital twin, like TCS and many companies are coming with digital twin. Actually, that IBM has started the digital twin, and they are collecting multiple sensor data and putting onto the like stack, and then they are researching all those stuff. And they will be like, if you are into motor stuff, like you have given example for fan. So if you get a little bit of rust, so he will like tell that user that over a time period it's gonna be get destroyed totally. So it will predict everything, it will tell that what cost it will be taking for to repair and everything. So these companies are coming with this kind of solutions.
Yeah, so that's coming to that. Yeah, that's how insurance company decides your premium, right? So for example, if you want to get a premium of for example a Creta car in Delhi, so the factors they will consider is how solid is your car, number one. How many challans? I don't know if they see that, but I am sure they have some sort of data. How many challans of overspeeding and things like that you have done in the last year or so, and where you live, how rocky are the roads. So more the rocky roads are there, there will be more chances that you will claim insurance. So they will increase your premium. So that's a very common practice in North America. So for example, if you live in Montreal, Quebec in Canada, your insurance premium is much higher if you live in Toronto, because Toronto is a downtown and most part of Montreal is still countryside. So they have more premium. So this is all hard coded, right? But what happens when an insurance company puts a small device in your car? They'll say that just install this device in your car. We will get some data and we'll give you insurance free for 1 year. So what kind of data they can get? They can have the device read the speed of your vehicle. They can have the device read how much you drive on bumpy roads, how much red lights you jumps, and based off that, they could have given you insurance free for 1 year, but they might charge a much higher premium depending on your activity. So data is definitely going to be a game changer in everything. So yeah, I quite agree with your research and things that digital twin and data, these things are gonna be game changer in future.
Yeah. So again, on a student point of view, I have a question. Like you are a software engineer, embedded software engineer, but from the college days, when you like code something and when you upload into the hardware, you have a tendency like you have to see into the like you have that curiosity. How will be it looking into the hardware stuff? And so joining the company and for the very start days, were you into the like kind of a hardware thing as well with your software domain? Like were into both looking into that domain as well?
Fortunately, I started working since the very first company who is totally into hardware. So the first day of my company, I was sitting in front of the computers, the single board computers that runs custom Linux and that goes inside different cars. So I would say I was fortunate enough to land a job in that company. So it was always about hardware. It was always about flashing something. It was always about seeing LEDs working in front of me. But I get your point, because more and more companies are going remote. More and more things are moving to the software, and I could see where the question is coming from. But for me, it was always about the hardware, and unfortunately, it still always will be about the hardware as for the foreseen future I see. Uh, but nevertheless, if people have some obligations back home, and the condition doesn't allow them to wait for the right hardware job, then I'd say go pick a software job and keep working at the side until you land the job you wanted.
Yeah, definitely. Now coming to the next question, what tech skills companies out there are looking when it comes to hiring any freshers in today's time, and what advice would you give to students who are willing to start a career in embedded domain?
Build in public. So the only advice I can give to anyone looking to find a job or looking to find an opportunity anywhere in this world, into any domain, is build in public. So do a lot of projects and document it. And what I mean by documenting is putting it out. Either it could be a GitHub repository, either it could be a blog post, it could be a small video on your YouTube channel. Just build in public, and don't think that people will judge me because I'm not good enough or my product is not complete. You don't have to make it for them. You have to make it for yourself. So I'll give my example. So I started writing blogs pretty late in my life, actually. So I started almost when I completed my engineering, to be honest. And I always wanted to write blogs when I was still doing projects in engineering, but for some reason I have this weird dilemma that I'm not good enough or my blogs will not be liked by people. But it's totally opposite. It doesn't matter. So what advice I could give is just start making project and do progress on public. So don't wait for the project to finish. For example, Twitter is a very amazing platform which I am also exploring a lot these days. So you could start a project and you could start a Twitter thread. For example, one of the project that got published in EFY magazine when I was in second year was self-watering planter. So it water
Yeah.
itself whenever the soil moisture is less, right? So I actually never published it. So that was one of the regret. So what I could have done if I have to go back in time, I would have written that on Twitter, the first tweet, I'm going to make a self-watering planter. The second tweet on the thread, I'll shoot a photo of all the components which I'm planning to use. The third will be the connection which I'll be going. So build in public. Whatever you are doing, do it in public. Let people know. Use a relevant hashtag. There is nothing wrong with marketing yourself. People think that it's wrong. I'm an engineer. I'm not a marketer. But at the end of the day, you need to find the right people who will give you the opportunities. And the right people will not come to you. You have to find the right people on the right platforms. And
Yeah.
instructables, if I say Hackster, Hackaday, Twitter are the platform where you can find the right people, right? And from there you can get jobs. From there you can get opportunities to be the co-founder in the startups. From there you can get some freelance work. From there you can just meet some people who could help you in your project. So the only advice I would say, just build in public. Coming back to the part where you are asking what skills are required, the only skill which is required and which will require for the rest of the capitalist society is problem solving. So be a good problem solver. Look for the problems around you. Look for the problems in your projects. Look for the problems in other projects. Foresee the problem that could have come. For example, if you're making a project, think of it from a product perspective. What if this project is converted to a product and 5,000 people are using it? What problems could they run into? Think about that. With that mindset, solve those problems. So once you have that mindset that I am a problem solver and I need to solve the problems, then you become very expensive for people to hire you, and they will be willing to pay anything if you are a good problem solver. So I will not say here that learn C programming language. I would not say here learn KiCad. I would not say here learn MQTT protocol, but I'll just say learn how to solve problem, learn how to see problems from a customer perspective, and learn how to solve them. That's the only skill that is required and will be always required in an industry.
I believe that's the very best advice anyone can ever give. So thank you, Ayan. Thank you a lot for doing this. It was great talking to you, and definitely I'm looking forward to have you again sometime. I hope a lot of people will gain values out of it. So thank you. Thank you for doing this.
Yeah, thank you, Saurabh, for having me. It was nice talking to you. Have a nice day.
Yeah, thank you. Same there.